In today's video, I want to give you a tour of the islanding backup functionality offered by the H.E.A.T Energy Gateway. The H.E.A.T Energy Gateway is a powerful energy management solution. It's vendor-agnostic, with self-learning prediction that helps you get the most out of your energy system. And best of all, you can set it up and adjust it yourself. You can add and remove devices as your energy system grows and changes. And you can change the operation goals as market conditions change as well. But the feature we are looking at today is islanding backup power with a seamless back transition. A lot of people today are installing battery energy storage systems. They're doing it to avoid peak power charges. They're doing it to accommodate increasing loads. And they're also doing it to take advantage of dynamic tariffs and other market conditions. The thing is, most battery systems today come with a grid forming capability. And that means that with the right EMS, you can also use your BESS to provide backup power, which then reduces fuel costs and generator maintenance while increasing your site's resiliency. The H.E.A.T Energy Gateway software comes pre-installed on an appropriate industrial PC for your site. It offers a web-based UI which can be accessed on the local network. Let's log in as a service technician. By logging in as a service technician, we are then able to take manual control of any device in the system. So the system that I've set up for today's video consists of a single grid connection, two battery systems of different sizes, two gensets, one being a CHP, and a measured load branch, which is the entire load of the system, and one single PV power plant of about 550 kilowatts. So we have a fairly complex on-grid site here. Let's access the control view to get a little bit more information. If we take a look at the public grid, we can see that we have a medium voltage connection. We have 20 kilovolts as the connection of our local site, as well as the external grid, because the breaker is closed, so we've got the same voltage on both sides. And the frequency is 50 hertz, a very stable 50 hertz, as this is the standard frequency here in Europe. If we switch to the battery system, we're going to see that it's on the low voltage network. It's operating at 400 volts. Same thing for the gensets as well. They're also 400 volt systems. And what this means is that we have a low voltage network connected over a medium voltage transformer to the public grid. So if there were a disturbance on the public grid, then the protection settings of the breaker would automatically pop the breaker open. This could be like a Rokoff event or a frequency spike or a voltage drop of some sort. Whatever the reason for this event, we're going to simulate that protection event by just manually taking control and opening up the breaker. And what we see is in the simulation, we just immediately continue supplying the loads in an island mode. And you can also see that we start up the genset for a little bit of support while in island operation. Now, in reality, when that breaker opens up, you will experience a short interruption of power supply. But the H.E.A.T Energy Gateway will restart the system, do a black start of your local site as quickly as possible. And with a BESS, this can be very, very fast. What we notice here, if you take a look, is that the local site is operating at a very smooth 20 kilovolts when measured at the grid breaker, and 50 hertz. But the public grid, we are simulating it as though it was unstable. So you see the public grid frequency going up and down, and the public grid voltage going up and down as well. If I take a look here, I get the information that the H.E.A.T Energy Gateway is currently observing the public grid and waiting for it to stabilize. We're waiting to see that the public grid is back and that it's stable before we initiate a back synchronization. After waiting long enough, the Energy Gateway will decide that the external grid is in fact stable and initiate a back synchronization routine. If we look here at the BESS, we can see that the Energy Gateway is modulating both the voltage and the frequency output on the low voltage side in order to try to match what it sees of the grid. So you can see the voltage and the frequency output of both the BESS and the gensets being modulated. If we look past the medium voltage transformer and go back to the public grid, we see that that medium voltage output is following the grid quite closely. Not perfectly, but pretty close. What we also see is that the frequency on the grid side is being matched just a little bit below what we're measuring on the grid side. This is called a frequency slip. Using a frequency slip ensures that eventually we will see a zero crossing point. When there is a zero crossing point, this allows a synchro check breaker to close and do a seamless back transition. Without any interruption in power supply, we will be connected back to the grid again, and you will see no flicker and no interruption. So I'm going to put this grid breaker back under dispatcher control. And when I do that, he's going to send a signal to the synchro check breaker, and he will close the breaker only when he sees that zero crossing point. And there it is. We're back on grid again. No interruption, and our system is back doing whatever operation was set by the user. In this case, we've chosen self-consumption to keep things simple, but you might be participating in different markets, doing a dynamic tariff optimization, or some other peak shaving functionality. If you want to learn more about what you can do with the H.E.A.T Energy Gateway, get in touch via our website or send us an email at info@heatsolutions.com. Let us simulate your business case and help you get more out of your energy project.